Alright, so graphing parametric equations would be very similar to what you would have done when you graphed Cartesian equations. It would go something like this. You make a chart here, and notice the difference here. For Cartesians, you would only have x's and y's because you usually only got one equation. You only get one equation with those. Here we have an extra parameter. We add another column on our table, t, and then we pick certain values for t, whatever you want. And so we could go with 0. When t is equal to 0, that would make x is equal to 1. When t is equal to 0, that would make y equal to -1. Okay. When t is equal to 1, that would make this 2. That would make this 2 minus 1, which is 1. When t is equal to 2, that would make this 3. That would make this 4 minus 1, which would be 3, etc., etc. 3, 4, 5, a few of these. 4, 5, 6, 5, 7, 9. So you go on and you plot these points. When x is 1, y is -1. When x is 2, y is 1. When x is 3, y is 3. When x is 4, you got 5, etc., etc. So the equation looks, roughly speaking, like this. And there you go. That's how you graph equations. You may say, well, that was too easy. Let's try something a little bit more challenging. And so you could go on to, say, this one. This one has a couple differences. First of all, it's a degree 2 in t, and second of all, note the way we wrote it. I did this on purpose so that we can emphasize the fact that often these are looked as functions of t. X is a function of t, so we're using the function notation. Still, the process is roughly speaking the same. 0, 1, 2, 3. You could plot a couple points here. And for 0, you would plug it in here, and you would get, of course, 1. For 2, you would get, for 1, you get 2, 3, 4, 5, 6. What about the squares? Here we go. This is 0 squared, that's 0, 1, 4, 9, 16, 25. This one is just squaring them. Alright, now we've got a bunch of points. When x is 1, y is 0. When x is 2, y is 1. When x is 3, y is 4. When x is 4, y is 9, etc., etc. And you get the sense here of a moving object. This one, you could makes a little note of here. This one was when t is equal to 0. This one was when t is equal to 1. This one was t is equal to 2, etc., etc. You see the moving trajectory of some object with respect to time. As time moves, of course, the object is moving. That's traditionally why, or how these came about to be extremely useful, parametric equations. Alright, maybe one more. Let's see. Let's try cleaning up this guy right here. Move on to the next page. Yeah, so next we're going to do ellipses and circles with parametric equations.